The goal here is to focus on completing the square as just a process and have to rely less on the picture. I will say that even when I'm doing just a process approach for this technique, I picture this thing in my head, even if I'm not necessarily drawing it out, because some of the steps are a little wonky. They're not exactly what we'd say intuitive, at least not until I think about what's happening. So if we give it a trinomial like x squared minus 10x plus 3, my first goal, if I want to get a binomial squared, is to try to figure out a number I can add and subtract to this expression so that this portion of it, these first three terms, can be written as a binomial squared. And to do that, I need to have a square. And to have a square, I need to have equal sides. So if I think about that area model, we know that the x squared accounts for this x and this x. And we know that this negative 10x has to be broken into equal pieces. So I'm going to always take half of that value. Half of 10 is 5. And now because I'm forced to use a 5, this portion of the square that we haven't gotten yet, it's forced to be a specific number. If I'm saying this has to be negative 5, and this has to be negative 5, then of course this square is negative 5 by negative 5. This completed square has to be 25. That's the picture. The process is just to think to yourself, let's take half of this number and then square it. 25. And then we have to balance that thing out. And the positive 3, we just need to keep track of it. It's still part of our process. So that's kind of like phase 1. Get the correct number in those blanks. The second part that seems weird to most people is what happens with these first three terms. So these first three terms are an expression that represent the area of this entire shape. We can see we have an x squared, we have an x squared. These two things do combine to make the negative 10x, and the 25 is here. It's the area of this big, beautiful square, and this square has sides of x minus 5 by x minus 5. So in terms of just a process, when I go to write this as a binomial squared, what goes inside of here is going to always be x, and then it'll be whatever you took half of, whatever you would have written here and here, half of that b value. So in this case, it's x minus 5. Now sometimes kids, when they don't have the picture in front of their face, they wonder, how did all of this become just this? And this is where picturing the picture is helpful. This entire trinomial represents this entire area, and this entire area can be expressed as x minus 5 times x minus 5, or x minus 5 squared. And then, of course, these last two things, we can't ignore them. They're still part of the program, so we have to put them together and say negative 22. It's all very crazy. And of course, if you want to check your work, which I know you want to do, graph this on Desmos and graph this on Desmos, and they would be right on top of each other if you did it all right. So now we'll do one, all process, no picture. Let me just write one down that'll work. And we're going to go no holds barred. I'm not even going to color code this stuff. I'd like you to try at this point. Why don't you pause it and get as far as you can. So I'll stand here like an idiot and stare blankly for a moment while you pause. And now you've unpaused. Let's just go through straight process. I know the focus starts on these first two terms. At x squared minus 8x, something will get added and subtracted, and that 12 has to be left around. So the first question I'm saying to myself is, what goes in those blanks? And I'm picturing a square. I'm like, it's got to be the same on both sides. So I'm taking half of this number and squaring it. Half of the negative 8 is 4. Squared is 16 and 16. The next piece is to take this portion and recognize that it represents the area of a whole square whose side is x minus 4. So that yellow portion becomes x minus 4 squared. And then we can't ignore these little guys over here. They combine to make negative 4. So this is a vertex form. This is a standard form. And if I want to know if I did it correctly, I'm going to go on to Desmos. I'm going to graph each of these and see that they match up. And be very proud of myself. If they don't match up, I might go through and actually draw the picture out and see what's happening. That's how we do it without having to draw a picture. Always take half of the x term and square it. Rewrite the first three terms as binomial squared. Sounds so hard when you say it with all the math words. Combine the remaining terms. Good luck. If you need help with this, please pop in. I have office hours, of course.